Alright, welcome back. We are now on part 2 of factoring polynomials completely. On part 1, we looked at the rational root theorem to figure out all of our possible rational roots. We also looked at Descartes' rule of sign, and we determined that we had 4 or 2 or 0 positive real roots that we were looking for. We also determined that we had 1 negative real root that we were looking for, which means we probably also have, and we don't know for sure, but we probably will have a pair of complex roots that we'll be looking for. So we want to keep that in mind. But first we're going to find as many real roots as we can, and then we'll worry about the complex one when we're done with the real ones. So first thing we're going to do is we're going to go back and look at our possible rational roots that we discovered before. And those rational roots that we had before were, okay, so we had, these were our possible real roots right here. Positive negative 1, positive negative 2, positive negative 3, positive negative 6, positive negative 1/2, positive negative 3/2, positive negative 1/4, positive negative 3/4. So we want to go and start trying some of these using synthetic division to see which ones work. So remember, you want to use synthetic division and the factor theorem to see if any of these are factors. And in the factor theorem, we want to see if we get 0 as our remainder on the synthetic division. So when we use our synthetic division, we want a remainder of 0. And if we have a remainder of 0, then we have a factor. And that's our whole goal, is to figure out which ones are factors. So easiest thing to do is start with the easier ones. Is there anything easier than positive 1? Not really. So let's start with positive 1 and see if it works or not. So we're going to take 1 and put it in. Remember, our original problem, our original equation was, alright, so our original equation was 4x to the 5th minus 8x to the 4th minus 19x cubed plus 22x squared minus 5x plus 6. So now we're ready to set up our synthetic division. So I've got a 4, I've got a negative 8, I've got a negative 19, a 22, a negative 5, and a 6. Notice it was in descending order. So we had our 5, then our 4, then our 3, then our 2, then our 1, and exponent of 0. So everything's accounted for. Now we're ready to start our synthetic division. So we're going to start out with positive 1, and then I'm going to go try negative 2 and keep going from there. So go ahead and pause, and I'll work it out, and then you can record the results. So after doing my synthetic division, you can see that I ended up with a remainder of 0. Because I got a remainder of 0, this means that x minus 1 is a factor of the original polynomial. That's exciting. I'm already partially there. So I found a positive 1. That means that I've got to have at least 2 now, because it wasn't 0. I found one that worked. This was a positive factor. Therefore, I should have at least 1 more that's a positive factor. So now I'm going to pick another one and try it and see if it works. So I'm going to go for another positive 1. I got positive 1 to work. So maybe now I try positive 2 and I see if positive 2 works. So let's go ahead and set that one up, and then we'll go from there. Now, as I'm working with positive 2, I have a couple of options. I can go back to the beginning, and I can use this original set of polynomial values, or I can use the new set. Remember, the new set corresponds to x to the 4th, x to the 3rd, x to the 2nd, x, and no x. So I can either use these original ones, or I can go to my new set and use them. If I use the new set, I do not need to use the 0 that was the result of the remainder. So I'm going to go ahead and use the new set just so it's a little bit less that I have to use for my synthetic division. So I'm going to use the 4, the negative 4, the negative 23, the negative 1, and the negative 6. So now I'm going to do my new synthetic division. So I'm going to go ahead and pause, and then you try it, I'll try it, we'll see what we end up with. Okay, when I worked out trying positive 2, this is the result that I got. I got 4, 4, negative 15, negative 31, and I had a remainder of negative 68. So that means that x minus 2 is not a factor. So positive 2 did not work. So when I go back up to my list, I can cross out positive 2. It did not work. So we come over here, we can get the pen to work, and we cross out positive 2. Positive 2 did not work. I know I need another positive value, so now I'm going to try positive 3. Again, trying the whole numbers are easier than trying the fractions, so only try the fractions if you have to. So now I'm going to plug in positive 3 to the same values, and we'll see if positive 3 works. Still using 4, negative 23, negative 1, and negative 6. So you go ahead and try it, I'll try it, and we'll check back with each other in a moment. Did you get the same thing? We got 0 as a remainder. That's awesome. So that means that 3 is a factor. So therefore, x minus 3 is a factor. In other words, positive 3 is one of my roots. So now I have found my second root. We already knew that 1 worked, now 3 works. And remember from our list above, we either had 4, or we had 2, or we had 0 positive real roots. So I know that I've already gotten this number. So I've either got 4 or just 2. Now, I have a pretty good idea, since there's only 5 possible real roots, because the degree of our polynomial was x to the 5th. Because that was our degree, there can only be 5 total solutions. So because of that, 2 of those I already know are positive real roots. And I know I have to have 1 negative real root. We already discovered that with Descartes' rule of signs. So I'm going to go ahead and go find that negative real root and then see what's left over. Okay. Remember that this corresponds to x to the 3rd. So this is my x to the 3rd term, this is my x squared, my x, my no x, and the remainder, which was 0. And it's always a happy face when we get a 0 as a remainder. So now I'm going to start trying some of my negative values that we discovered for our possible rational roots. So I'm going to come up here, and we know that 3 worked, positive. So I'm going to go back and I'm just going to try negative 1, and if that doesn't work, then I'll try negative 2. I'm only looking for one of them, so start with your easier ones and then work your way to your fractions if you have to. So let's go ahead and set that one up, and then we will pause it and you can see what you get and we'll compare answers. So for this one, we know that 3 works, so now I'm going to use the 4, the 8, the 1, and the 2 as my values for my synthetic division. So go ahead and pause, and we'll come back and compare results. Did you get what I got? I got 5 as the remainder. So what does that tell us about -1 or x plus 1? It tells us that x plus 1 is not a factor of our polynomial. So we can get rid of that one. It didn't work. So now let's try, for lack of anything better to do, let's try -2. And let's do the same thing. So you go ahead and set it up, and we'll compare answers in a moment. Do you see what I see? Woohoo! We got 0 as our remainder again. So that means that -2 or x plus 2 is a factor of f of x. So we have now found our negative real root. So -2 was our negative real root that Descartes' rule of signs said we would have. That's our one real root that it predicted. So now what's left is, this is my x squared, this is my x, and this is my no x. We're left with 4x squared plus 1 as the remaining part of our polynomial. So you can keep trying all of those real rational roots if you want to, the possible ones. Only the positive ones though, because all the negative ones we already found our negative ones, so we can't have any more negatives. So you can keep trying the positives, or you can look at this and see if there's a way to solve it. Remember, we have basically 3 methods for solving this quadratic now. Once you get it down to a quadratic, you have 3 methods for solving. And if you will take the time to write these down, it will be very beneficial for you. So I'm going to go ahead and pause and give you a moment to copy it down. Alright, so the 3 methods: completing the square, factoring, and quadratic formula. The first one is the factoring. That's what we've been doing. If I can rewrite this one, this is the same as 4x squared minus a -1. And so you can see where I'm going with this, hopefully. If I break this down, this is a perfect square, so it's 2x times 2x. -1 just happens to be I times I. And to make the middle term cancel, we got a positive and a negative, and so now we have it factored. And if we finish solving this, we've got 2xi, or 2x plus I equals 0. 2x minus I equals 0. So 2x is equal to a negative I. 2x is equal to a positive I. We divide by 2, and we get that x is equal to -1/2 I. That's an I, not an x, sorry. And the other one, x is equal to +1/2 I. Okay, those are our 2 solutions. If you're writing them as factors, that would be x plus 1/2 I and x minus 1/2 I. Alright, if you're doing it by quadratic formula, A is 4, B is 0, C is 1, plugging in, we get -0 plus or minus 0 squared minus 4 times 4 times 1 all over 2 times 4. Simplifying, you have negative 0 plus or minus, which the 0 is just really not there. Inside, we have 0 take away 16, which is a negative 16. On the bottom, we've got 8. Simplifying a little bit more, square root of a negative 16. Square root of 16 is 4. Square root of a negative is I, and that's over 8. That's positive or negative. That's what that tells me. So we end up with positive or negative I over 2, which is positive 1/2 I and negative 1/2 I. And you would follow similar situations and get the same answers for completing the square. You will turn this off. I will finish doing the completing the square, and then you can see the result for that as well. Actually, since we don't have a middle term, we don't even need to complete the square. We can just solve for x. So that's what we're going to do. Let's solve for x. Just solving it the regular way we would solve a square root problem. We're going to subtract 1 to both sides. So we get 4x squared equals negative 1. We're going to divide by 4, and then we are going to square root both sides. Now because it's a negative 1/4, when I square root both sides, I'm still going to take the positive or negative of the square root, but because it's negative, I have to take care of that negative with an I. So the square root of 1/4 is 1/2. To take care of the negative, I have to put this little I here, and so you can see that we end up with our two solutions again. Positive or negative 1/2 I. So positive 1/2 I and negative 1/2 I. Whichever way you choose, you get the same answers 3 different ways. Thank you. Hope you have a good evening. We'll see you tomorrow. Bye.